What's up, everybody? It's Dan from Sage Math Tutoring, and back with another video. This time, just going to cover some problems and concepts to help a student of mine prep for an upcoming quiz. Um, and the quiz is going to, and the quiz has to do with like the sum of interior angles and things like that, but also parallelograms and rectangles in particular. And for this video, we're going to just talk about parallelograms and rectangles. So let's dive in. So, first of all, the way you know you're dealing with a parallelogram uh, is if the opposite sides are congruent. Okay. So, that would be enough information to know that you are dealing with a parallelogram. You might have some four-sided figure, and you don't know anything about this four-sided figure, but you know that this side happens to be the same length as this side, and this side happens to be the same length as that side. Well, then you know you're dealing with a parallelogram. Another way of knowing you're dealing with a parallelogram is if the opposite angles happen to be congruent to each other. Okay. So, once again, if you don't know anything about this four sided figure, but you do know that the opposite angles are congruent to each other, then this thing is most definitely a parallelogram. It's also the case that if you have a quadrilateral, a four sided figure, and the diagonals are sort of cutting each other in half, also known as bisecting each other, that would result in a scenario where this part is equal to that part, this part is equal to that part. That would be enough information to know that you are indeed dealing with a parallelogram. And then finally, we have this scenario where if it's the case that one pair of opposite sides are parallel and that same pair of opposite sides are congruent to each other, then it's a parallelogram. Now, notice how that's not the same as this situation, where maybe these are congruent to each other. That would not be enough information to know whether or not this is a parallelogram. Okay. So, for my student watching, just remember these are the four sort of conditions. And in a sense, these are patterns, they're visual patterns that help you know whether or not you are indeed dealing with a parallelogram. Okay, let's take a look here. Just kind of barrel through a few of these. Determine whether each quadrilateral is a parallelogram. Yes, it is due to that first condition. This is a parallelogram because one pair of opposite sides happen to be parallel and they're congruent to each other, right? This is not enough information. Now, if we knew that these were parallel, well, then, yes, similar to problem number 10, that would be enough information to know that these are parallel. Okay. This situation is such that this diagonal is, of course, getting cut in half, but we don't know if the other diagonal is getting cut in half. So, therefore, this is not enough information. Unlike problem number 13, where it's very obvious that the diagonals are bisecting each other. So, that is a parallelogram. And let's see. It's the case that the red sides are parallel. And the reason I know that is because you can kind of think of this situation such that the red lines go further like this. And you can kind of treat this like it's a transversal. And if that was the case, these would be obviously considered to be same side interior angles, and they're supplementary. So the bottom line is, since these are supplementary, we know for a fact that the red lines are parallel. And for my student watching, just remember when I say supplementary, what I mean is these add up to 180. Okay, so if same side interior angles add up to 180, then it's definitely the case that these lines are parallel. But the problem is that's still not enough information to know that the quadrilateral is parallel, because we don't know, for example, if the black sides happen to be parallel to each other. So that's just not enough information. We also don't know if that's congruent to that. And that would be helpful to know that. Let's see. I don't care about proofs. I don't know if I even care about the yellow truck, to be honest. These are always easy. I mean, well, it's a proof. Nah, my student's teacher is not getting into proofs. Okay, find x and y so that the quadrilateral is a parallelogram. Okay, so I do believe something like this could be on the quiz. So we know that so that the quadrilateral is a parallelogram. We know already, according to this, that this angle happens to be congruent to that angle. So we want to find values of x and y that, in a sense, would cause this quadrilateral to be a parallelogram. And I think we can all see that if this angle was congruent to that angle, right, well, then it would be a parallelogram. So therefore, let's go ahead and force 106 to be equal to 3y plus 19. For my student watching, I know she knows you can subtract 19 from both sides, and that would give us 87. And then dividing both sides by 3 would give us 29, I do believe. So that would be something that would correspond with this quadrilateral being a parallelogram. But let's once again look at the directions. Find x and y so that the quadrilateral is a parallelogram. Okay. Well, yeah, if y was 29, this would indeed be a parallelogram. And if it's a parallelogram, well, then I think we understand that if it's a parallelogram, then the red sides would also be congruent to each other. And therefore, we can set up another equation that says 2x plus 9 equals x plus 11. Subtracting x from both sides gives us x plus 9 equals 11. Subtracting 9 from both sides gives us x equals 2. So that would be the answer to that. Looking at problem number 19. One thing that I have not really emphasized that much with my student is the fact that, parallelograms have all kinds of properties. In fact, for my student watching, you took a picture earlier of the various properties of parallelograms. For example, we know that has to be congruent, that has to be congruent, and so on. We know these things, right? However, one thing we did not really talk about too much, but it is sort of implied, is the fact that if you were to do like a Z here with one of the diagonals, well, the alternate interior angles here, they would be equal to each other, right? And that's a feature of sort of parallel lines with a transversal. Hopefully, my student watching, you do remember that alternate interior angles are equal to each other. So I'd like you to think of this like Z shape and think of the insides of the elbows of the Z. Now, similarly, you could also consider this diagonal and notice how this is the Z shape in that case. And then, the angles in that case would be these, right? So one way or the other, you just have to kind of get good at spotting that Z pattern inside the parallelograms. Well, that is exactly what we have right here. I think my student watching understands that this has to be congruent to that if this is indeed a parallelogram, all right? And they're basically, once again, in the direction saying, find the x and y so that the quadrilateral is a parallelogram. In other words, you could almost think of it backwards. It's like, if it's a parallelogram, what must x and y be, okay? Well, hopefully we're seeing that this 5y minus 13, well, that is a label for this angle. Notice the degree symbol, by the way. This 3y plus 5 is a label for this angle. So I think we understand we can set up the equation thusly, solving. I'm going to subtract 3y from both sides. That gives me a 2y over there. I'm going to add 13 to both sides. That would give me an 18. We're going to divide both sides by 2. That's going to give me a 9. Now, I think for my student watching, she also knows that if this thing is to be a parallelogram, then these blue sides must therefore be congruent as well. So we are looking at 4x minus 17 equals 2x minus 1. Subtracting 2x from both sides and adding 17 to both sides would give me this. Dividing both sides by 2 would give me that. Okay, so that's that. Looking at this one over here. Okay, so if this is to be a parallelogram, then these red double rainbow angles have to be congruent to each other. They're highlighting this Z shape. So hopefully my student watching knows that the yellow ones must also be congruent to each other. And this 1/4 x degrees is indeed pointing to that. And this y minus 8 degrees is indeed pointing to that angle. So with regards to the red angles, I think we understand 4x minus 8 equals 8y minus 12. And with regards to the yellow angles, we're looking at y minus 8 equals 1/4 x. So this is particularly challenging because we have an x and a y in the same equation. We have an x and a y in the same equation. So this is actually a system of equations. Now, for my student watching, I'm going to follow through with this. However, I would actually be a little bit surprised if the teacher is throwing a problem like this at you, because this requires a relatively sophisticated algebra maneuver, which I'm about to do. Okay. It's sort of a pivot towards higher level algebra, which would be a bit surprising for your teacher to kind of do with y'all at this stage. So I will go ahead and do it though. So one way of solving this whole situation is to use what's called the substitution property, and that means solving for one of the variables here. Now, I don't like this 1/4, and I see that there's an opportunity to get rid of it right away while actually, quote unquote, solving for x right now. And the way I could do that is I could multiply both sides by a 4. Okay, so let's make a dividing line. And as a result of that, the 4 would distribute in there. That would become 4y minus 32. And this 4 would cancel with the denominator down there, which is really a beautiful thing. And then we have x. All right. And then you just pause because we now have one of the variables by itself. So the bottom line is what this means is anytime you see an x, you could replace it with a 4y minus 32. Well, that's what we're going to do right here. Okay. So we have a 4 times some value. What is that value going to be? Well, instead of writing x, I'm writing 4y minus 32 in there. Okay. And why are we doing that? Because now we're about to have only one variable to solve for, which is y. So we have this, we have 8y minus 12. Now you have to distribute. Next thing you know, you have 16y minus 128, I believe, minus 8. And then we have this 16y minus 136 equals this. Let's go ahead and subtract 8y from both sides. And let's go ahead and add 136 to both sides. And that would give us, I guess, 124. I'm pretty sure about that. Dividing everything by 8 would give us 15.5. Yet another reason why this is sort of a weird problem, because it's giving us a weird answer there, but that is true. Then to find x, all you'd have to do is use this equation here, because x is whatever 4y minus 32 is. So that would be x equals 4 times, that 15.5 that we just found, minus 32. And if you were to go through the motions with that, you would see that x is 30 ultimately. Okay, so that is the answer to that one. Once again, for my student watching, maybe don't worry about that. Okay. Graph each quadrilateral with the given vertices. Determine whether the figure is a parallelogram. Justify your answers with the method indicated. So for problem number 24, what would that look like? -3, 4 is here. That's A. B is 4, 5. That would be here. So that would be B. And C is 5 comma -1, so that would be down here. And then d would be -2 comma -2, which would be down here. So certainly looks somewhat like a parallelogram. Now, this is the stuff where, for my student watching, I do think this is actually important. Um, you know, they are talking about the slope formula. I would strongly encourage my student to just be very meticulous and organized with regards to how you go about this. Okay. Now, we have the coordinates kind of waiting for us here, which is nice. It's already written for us, but we can set up a structure where we know we're going to be taking the slope. And let's be very clear, the slope formula is this. Okay. And we're going to be taking the slope of all the sides, right? So I'm going to make this structure, okay? And we're just going to duplicate it because we're going to do it a bunch of times, right? We're going to do these. We're going to do 4 of these. So on your scrap paper for my student watching, you might want to set that up, you know? And also be clear that this would be the slope, for example, of AB. This next one would be the slope of BC. This next one would be the slope of CD. And this next one would be the slope of DA or AD. Okay. And then, you know, get clear on AB, right? So if we're doing AB, the slope of AB, you could always call this x1, y1, and then x2, y2, and then just plug it in like that. So it would be 5 minus 4 all over 4 minus -3. And what is that? 5 minus 4 is 1. So that's 1/7. Okay. Looking at the slope of BC. Well, BC is right here. We could call B x1, y1. We call C x2, y2. So then it's just -1 minus 5. And then we have a 5 minus a 4. And that would be -6 over 1. Okay. So that's that one. This is the slope of CD. So you can take these into account right now. We're looking at x1, y1. We're looking at x2, y2. And I think you would agree that would be -2 minus -1. That would be -2 minus 5. And then we have, that's really -2 plus 1, right? So that'd be -1. And then down there is -7. Notice how that's actually positive 1/7. And also notice how that matches this one here, which is these are opposite sides in the parallelogram, and they have the same slope. And that means that the opposite sides are parallel. Okay. Now this one should be -6 itself. By the way, this is really just -6. This one should also be that. So let's investigate those, right? That is, of course, the slope of AD. So you could put your A, put your D over here. And I think you would agree we're looking at x1, y1, x2, y2. And that would be -2 minus 4. And that would be -2 minus -3. Now, -2 minus 4 is -6. And then -2 minus -3 is really the same as -2 plus 3, which is really just 1. So that's -6. And that does indeed match this one. So in a sense, we've proven that this thing is a parallelogram because the opposite sides have the same slope, and therefore the opposite sides are parallel. Okay. Now, I'm not going to do all of these, but I think for my student watching, you're probably getting the gist of that. I am going to do this one right here, though, because they want us to now use, of course, the distance formula. to basically prove that opposite sides are the same length, okay? So I feel pretty confident that my student watching knows what's up with this. I do want you to watch this, though, to just really get acclimated to a nice organized approach of, when it comes to finding out, um, you know, these measurements and so on. So we have -4, we have -3, 1. That's right here. We have 4, comma 3. That would be right around here. That's L. And then finally, 3, comma -3, which would be down here. And that's D, okay? So then you could connect these. And now we're using the distance formula. So we, first of all, know, hopefully, that the distance formula is this, okay? X2 minus X1, Y2 minus Y1. And what's it going to be? Well, it's going to be a whole bunch of those. It's going to be 4 of these, right? And I will set that up right now. So it's going to be 4 of them. And once again, for my student watching, I would definitely go about, drawing those structures. And then it's going to be the distance between J and K, followed by the distance between K and L, followed by the distance between L and M, followed by the distance between M and J, I do believe. And I'm realizing that I should not have called that a D, right? I should have called that an M, and that's 3, comma -3. So that's an M, my bad. Okay, then looking at this whole situation, well, first of all, by the way, it will be subtraction across the board. And we want the distance between J and K. Well, what is J and K? J and K is right here. You could call the -4, comma -4 X1, Y1. That could be called X2, Y2. And then that would be -3 minus -4. And 1 minus -4. Okay. And what I would do for my student watching, just go off to the side with it, honestly. That's going to become something squared plus something squared. No need to rush the process. Okay. Just go off to the side and be like, okay, -3 plus 4, right? So that would be a 1. No need to rush it. 1 plus 4. Okay. So that would be a 5. And then you just kind of go over here again. That's going to be 1 plus 25. And I know it's tedious, but just go over here again, and it's radical 26, okay? Now, I think for my student watching, you probably know this is probably going to be radical 26 as well. But anyway, let's look at the distance of K and L, right? Well, what is K and L? K and L are these over here. And looking at those, we could call this X1, Y1, X2, Y2. And therefore, we are looking at 4 minus -3. We are looking at 3 minus 1. What would that be? Again, taking our time, it's going to be something squared plus something squared. That would be 4 plus 3, so that will be a 7. This would be a 3 minus 1, which is a 2. And that would be a 49 plus 4, which is 53, right? So that's radical 53. And now we're looking at the distance of LM. So LM, of course, is here. And we are looking at X1, Y1. Now, for my student watching, notice how I am indeed labeling the points. I would actually encourage that. I know some of these things seem tedious and like not worth it, but I actually think it would be worth it. So, and then we have -3 minus 3. Okay. It's going to be something squared plus something squared. So that's 3 minus 4, which is -1. -3 minus 3. That's -6. Okay. Not rushing. -1 squared is 1. This is a -6. A -6 squared is 36. And that is radical 37. Now, this does not match that. So, therefore, and these are opposite sides. So, in other words, the length of this side, which is LM, does not match the length of JK. LM does not match the length of JK. So, therefore, this is not a parallelogram. So, we can actually stop right there. Okay. So for my student watching, just know that would be a nice organized approach to this. It only sort of takes long because I'm talking while I'm doing it, I'm explaining it, but it really shouldn't take too long for you to just barrel through, draw the structure, maybe even with empty parentheses in the beginning, then begin the process of filling in the parentheses, labeling x1, y1, x2, y2, and so on. Okay. So that's that. Just kind of looking at a few of these. I don't want to do all of them. This one, so ChatGPT disagreed with me earlier, but I'm going to stand by what I said before. There's not enough information to know that this is a parallelogram because there's just no pattern that talks about this scenario. We know that that's equal to that, but we don't know that this is equal to that, right? So that's kind of a problem. We know that this is equal to that, but we don't know that this is equal to that. And we also don't know that these are parallel to each other. So to me, that this scenario that's being described doesn't fit any of the previous patterns that we talked about, okay, on the first slide. So I'm going to say not enough information. All right, looking here. Quadrilateral ABCD has vertices of those. Yeah, I would plot that. We have A at 0, comma 1. That's right here. We have B at 1, comma 4. That would be here. We have C at 5, comma 5, which is here. And we have D at 4, comma 2, which is around there, right? So, looking something like that, I guess. Which of the following can she use in her next step to show that this is a parallelogram? Could she use the slope formula to show that AB is parallel to... Okay, so she already used the slope formula to show that BC is parallel to AD. So she's already established that the blue ones are parallel to each other. So she's already established that according to the problem. And then the question's asking, what else could she do in addition to that to show that, yes, this is actually a parallelogram? Well, Roman numeral 1 is saying she could use the slope formula to show that AB is parallel to CD. Yes, if she did that, then she'd have the blue sides would be parallel and these black sides would also be parallel. And that is enough information to know that it's a parallelogram. Roman numeral 2 says she could use the distance formula to show that BC is congruent to AD. Yes, if she shows that this one is congruent to that one, that was the fourth pattern that we had talked about before. For my student watching, you may want to just study those patterns, to be perfectly honest. Let me bring them back up. So here they are. And basically what Roman numeral 2 is talking about is that this person could use this pattern right here, where it's already been established that the blue ones are parallel. So this person could use the distance formula to show that this length is the same as that length, which is what's communicated in this pattern. I have a feeling I already know where Roman numeral 3 is going. Roman numeral 3, if it used distance formula to show that AB is congruent to CD. So no, that there's no pattern here that talks about how that would be enough information to know that it's a parallelogram. Um, to you know, essentially, what's being communicated there is that we would know that these are parallel, and we would know that these sides are equal. But that's not one of the patterns that we had discussed before, right? There's nothing here that talks about this situation. So therefore, this would not be enough information. Okay, so that's that. Um, we're looking at Roman numeral 1 and Roman numeral 2 only then, which is answer choice C. Okay, and quadrilateral, blah, blah, blah. This is that, this is that, this is that. For what value of x is quadrilateral? WXYZ, a parallelogram. Well, I'm not going to do the whole thing, but what I would suggest to my student is WXYZ, definitely draw it, right? WX is, 4x minus 15, XY is 4x plus 20, YZ is 3x plus 5, ZW is 6x minus 20. And they want to know what value of x would cause this thing to be a parallelogram. Well, the good news is you only need to set these equal to each other and solve for x, right? Because if it's a parallelogram, we know that that would be equal to that. Okay, so that's that. Don't know if I want to go there. This is more advanced. I don't know if the teacher would do that. So, yeah, that's very abstract. I don't know if the teacher would do that, but let's see. 51 are what are ways to determine two pairs of congruent angles. Well, it's really just quizzing you on this information, really, Um, which are the ways to determine that a quadrilateral is a parallelogram? Select all that apply. The quadrilateral has two pairs of congruent angles. Well, it seems like it's talking about this, but it is the case that they could be describing this, where that's congruent and that's congruent. The most important, and that's not a parallelogram, right? So this is not good because that's not necessarily a parallelogram. What's important that it's two pairs of opposite angles, um, which is right here actually. So the quadrilateral has both pairs of opposite angles congruent. Yeah, so that would work because the opposite angles need to be congruent. Part B, the quadrilateral has both pairs of opposite sides congruent. Yes, that's right here. So we're happy with that. The quadrilateral has one pair of opposite sides that are parallel and congruent, like simultaneously parallel and congruent. Yes, that is this scenario that we had discussed before. And the quadrilateral has diagonals that are different lengths. No, that's not enough. The diagonals certainly need to bisect each other, that's for sure. But that's not what they're saying. Okay, so let's move forward. Okay, so now we're talking about rectangles. So for my student watching, just remember a rectangle is a special type of parallelogram that has 90 degrees at the corners. That's one of the things that's special about it. Another thing that's special about it is that the diagonals are equal to each other. Okay, now that's not always the case with all parallelograms, right? That's the case with rectangles, though, where literally the length of this red diagonal is the same length as this red diagonal. So I don't want to deal with this. I don't like these. So let's just get into the nitty gritty here. Quadrilateral, blah, 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 is a rectangle. Find WX. Okay, so we will take this and use it for this problem. We're looking at problem number 14. ZY equals 2x plus 3. Okay, cool. Label it. WX is x plus 4. Find WX. Okay, well, they have to be equal, right? You would set these equal to each other, solve for x, and then for my student watching, hopefully you understand, of course, you would be plugging x back in after that, okay, to find WX. So cool. What else do they say on the next one? Py is 3x. That's this. Py is 3x minus 5. Wp is 2x plus 11. Find Zp. Okay, well, all right, that's an interesting one. So, one thing that is true about rectangles, other than these factoids, okay, is sort of related to the fact that these diagonals are equal to each other. Um, as is the case with any parallelogram, the diagonals are cutting each other in half, right? However, since the diagonals are of equal length, this piece is actually equal to this piece. Okay, so I'll throw a double tick on that. And this piece is actually equal to this piece. So I'll throw a double tick on that. So I would say these maybe should be the visuals that you need to remember. 90 degrees, definitely at the corners, but also this is true, okay? And the red things are equal to each other. Now, therefore, when they ask for, in this problem, what are they asking for? They're asking for ZP. We will make ZP yellow. They're asking for the yellow thing. Hopefully, you understand the yellow thing is going to equal the blue thing. Or we can say the yellow thing is going to equal the red one. Now, for my student watching, I'm pretty sure you know that the blue thing equals the red one. So that's going to become 2x plus 11 equals 3x minus 5. You would solve for x. I do believe it would be like 16, and then you would plug x back in, and then you would know what that yellow ZP is because you would plug 16 in to either x for the blue one or you would plug 16 into x for the red one. Okay, so that's that. Next one. The measure of ZYW, so that's an angle. ZYW, that's right here, is 2x minus 7. The measure of WYX. WYX is right here. That, according to them, is 2x plus 5. And they want to know what's the measure of ZYW, which is, the first green one that we had talked about. Well, it would be nice if we knew what x was, right? If we knew what x was, we would just plug x into this, and then we would find out what ZYW is, right? So hopefully my student watching understands that this little green angle plus this double rainbow angle, well, that has to be 90 degrees, right? Because it's 90 degrees at the corner. So I think we understand it would be 2x minus 7 plus 2x plus 5, and that would equal 90 degrees. And you would just use algebra to solve that. Whenever you get x, you would plug it into this because we are indeed trying to find the green one here. Okay. I do believe, let's see, ZP is 4x minus 9, so that would be this. PY is 2x plus 5. That's this one. Yeah, you could set them equal to each other as well. So that's that one. Looking at stuff. Looking at this one, we just talked about that. Looking at this one, angle XY, XZY, that's this, is a certain amount. XZW is a certain amount. Yeah, they add up to 90. I feel like we just did one like that. Problem number 19. If ZXW is a certain amount, what is that? ZXW, that's this one. And WZX is a certain amount. Okay. Find ZXY. ZXY is this one. Okay. Yeah, well, that one's actually tricky. I will go through the motions with that. So that's x minus 11. They told us that this one is x minus 9, and we're trying to find the blue triple rainbow. Okay. Um, this red triangle is a right triangle. We're going to bring it down here. Okay. This angle here is x minus 9. This angle here is x minus 11. And we know that this is 90, right? So we know that 90 plus x minus 9 plus x minus 11 equals 180, right? And you could do like terms. We have 2x, and then 90 minus 9 is 81. 81 minus 11 is 70, I guess. So that would be this. Subtracting 70 from both sides would give us 110. X is 55. Now, if x is 55, well, that would make this angle right there, I'll bring this, we'll make it a little bigger. This angle right here would be 55 minus 11. And then I think we can see that that would be 44. Now, if this angle is 44, well, we know that this 44 plus the blue double rainbow is going to equal 90. So the blue double rainbow is 90 minus 44. So what's 90 minus 44? That would be 46. And that's the answer. Okay, graph each quadrilateral with the given vertices, determine whether the figure is a rectangle, justify your answer using the indicated formula. Okay, so of course, very similar to the one that we did before. However, now we're dealing with rectangles. So we do have to be on our game. They want to know, is this an actual rectangle? And they want us specifically to use the slope formula to find it out. So plotting the situation, we have -2 comma 4. That's this. For x, it's 5 comma 5. That would be right around here. For y, it's 6 comma -2. That would be down here. For z, it would be -1 comma -3, which is down lower like that. Okay. Now, kind of looks maybe like it could be a parallelogram, certainly. It looks like it could be a rectangle. Now, they want you to use the slope formula. Now, that's code for find the slope of all the sides, okay? Now, once again, it will be usage of this slope formula. So we can just remember that, right? Maybe write it down if we have to. And specifically, it will be m equals something minus something all over something minus something. And then I'm going to go ahead and create my overarching structure right now. And as I did before, we are going to, was it W, X, Y, Z, right? So this will be WX. This will be XY. This will be YZ. And this will be WZ. Okay. Now, focusing on the slope of WX, we'll call this one X1, Y1, X2, Y2. So I think we agree that would be a 5 minus 4. That would be a 5 minus -2. And once again, for my student watching, just go off to the side. 5 minus 4 is 1. 5 minus -2 is really 5 plus 2, which is a 7. That's a beautiful thing. Looking at the next batch, which has to do with XY. So that would be X1, Y1, X2, Y2. That therefore would be -2 minus 5, 6 minus 5. Then we have -7. This should be just a regular 5, right? So let's fix that. So that would be -7 over 1. Okay, that's good information. Looking at the slope of yz, let's go ahead and call this x1, y1. We'll call this x2, y2. And that would be 3 minus negative 2 all over, oh, that negative 3, rather, minus negative 2, pardon me. And then negative 1 minus 6. So negative 3 minus negative 2 is really negative 3 plus 2, which is really negative 1. Negative 1 minus 6 is really negative 7. So that would become a 1/7. Now, finally, we could call point W x1, y1, and point Z x2, y2. So that would be negative 3 minus 4. And that would be negative 1 minus negative 2. Negative 3 minus 4 is negative 7. Negative 1 minus negative 2 is the same as negative 1 plus 2, which happens to be 1. So that is that. Now, notice how opposite sides have the same slope, which is a beautiful thing because that, in a sense, proves that we're at least dealing with a parallelogram. But we want to know if it's a rectangle. That's what the question's asking. So for my student watching, just know that anytime they are trying to get you to tell them if it's a rectangle, you have to look at the adjacent slopes, or we could say the next door neighbor slopes, and see if they're opposite reciprocals of each other. So do you see how 1/7, the opposite reciprocal of 1/7 is negative 7 over 1. It's opposite because this is positive and this is negative, so the signs are opposite. And it's reciprocal because this 1/7 just got flipped upside down. Similarly, these are opposite reciprocals of each other. Similarly, these are opposite reciprocals of each other. And similarly, these are opposite reciprocals of each other. So that means there's 90 degrees at the corners. So if the directions are asking for you to sort of prove whether or not these points form a rectangle, that's the analysis you have to do. It's not enough to know that opposite slopes are, parallel, right, or the same, right? You have to go one step further and check on the next door neighbor slopes and see if they're opposite reciprocals. Okay, so I think my student gets that. Now, it gets interesting. I will say I'll only do one more now because these are sort of redundant. We want to see if that's a rectangle using the distance formula. So J would be at 3, which is here. K would be at negative 5, comma 2, which would be around there. L would be negative 4, which would be down there. And then finally, M would be at 4, comma negative 3, which would be around there. Looks a bit like a rectangle. And they want you to prove whether or not this is a rectangle using the distance formula. Now, for my student watching, I want you to just pump the brakes because they're not asking if this is a parallelogram. If they were asking if it's a parallelogram and they wanted us to use the distance formula, you remember what we did. We had to find the length of all 4 of these, right? But now they want to know if it's a rectangle and they want us to use the distance formula to do so. So you'll actually be happy to know that this is going to be less annoying than what we did in the beginning. Okay. What we could do to find out if it's a rectangle is we could find out if the diagonals are equal to each other. Because isn't that a feature of rectangles? So let's check. We would have to find, well, first of all, we're using the distance formula. Let's remind ourselves of what that is. Y2 minus y1, right? And all we need to do is find the distance as it pertains to 2 things, right? the distance as it pertains to the red one, and the distance as it pertains to the blue diagonal, right? And let's be thorough. This is the distance of KM, and this is the distance of JL. Now, for the distance of KM, it would be helpful to call this x1, y1, and this could be called x2, y2, okay? And therefore, it would be 4 minus negative 5, negative 3 minus 2, right? And then once again, I would go off to the side. This would therefore become something squared plus something squared, namely 4 plus 5, which is 9, negative 3 minus 2, which is negative 5. And I think we can see that would be 81 plus 25. And that would end up being 106 in there. Okay. And doing something similar with the distance for JL, we can therefore call J x1, y1. We could call L x2, y2. Therefore, we're looking at negative 4 minus 3 and negative 4 minus 3 again. And of course, that's going to be something squared plus something squared, namely negative 7 squared, negative 7 squared. And then that is 49 plus 49. And then that would be 80 plus 18, which is 98. Okay, so in that moment, we have one diagonal that happens to be radical 106 in length, and another diagonal that happens to be radical 98 in length. So therefore, the diagonals are not equal to each other. All right, these are not equal to each other. And therefore, this cannot be a rectangle. Now, this could be a parallelogram, but it cannot be a rectangle for that reason. Okay. So that is the situation with this one. So for my student watching, if they're asking if this thing is a parallelogram and they want you to use the distance formula, I think you're probably getting that you have to find the length of all four sides, and you have to find out if the opposite sides are the same length, right? However, if they're asking you if it's a rectangle, then what you can do is find the length of diagonals, which actually cuts your work in half because you only need to find the distance of two segments, okay? And if the diagonals are equal, then yes, it's a rectangle. And if the diagonals are not equal, then no, it's not a rectangle. Now, I do believe that probably in this one, right, we just finished this one, but this one is another one. It's probably the case that the two diagonals would equal each other here, okay? And as far as using the slope formula to find out if if a quadrilateral is a rectangle, just like I said before, yeah, you have to check the next door neighbor's slopes and see if they're opposite reciprocals of each other. All righty. So that is that. I do hope that that is helpful. And for any other students watching as well, hopefully that was helpful for you as well. And I will talk to you all later. Bye.